Hello students! Welcome back to Algebra 1b. Today we're going to talk about mathematical models using exponential growth and decay. Now this is a great lesson because this is where we start to use exponential functions for things that everybody's going to use at some point in their adult life. So, to start off simple, you invest $1,000 into a bank account that yields 3% interest every year. So what this would mean is that at the end of each year, the bank would look into your account, see how much money you have, and they would give you 3% of whatever you have, kind of as a thank you for keeping your money in the bank. Now, the bank's giving you that money because they're loaning it out to other people and they're charging them higher interest rates. So, without getting too far into that, let's see what happens with that. First of all, I'm going to get 3% interest on any amount of money that I leave in this bank. So how do I figure that out? Well, in order for us to figure out a percent, I want to convert this into a decimal. So I've got 3%. And in this percent, the decimal goes right there next to the 3. Now, not to get too nitpicky about the math, but the word percent means per. When we say per, like miles per hour, this is for every. And then cent, we should know, means 100. So when we say 3%, that means 3 for every 100. If we wanted to change that into a fraction, we could go 3 divided by 100. Or the trick that a lot of us learn in elementary school is we take this decimal point right here and we move it over 2 times. So that would make it 0.03. That's how we express it as a decimal. So, what a lot of students will do is they'll say, okay, so I've got 1,000, and then I'm going to multiply it times 0.03. And that's going to equal 30. Now, there's a mistake here, because if I put $1,000 into a bank, and I come back later, and I only have $30, and they say, yeah, we gave you 3% interest. That's a bad deal. I don't want to have $30. I want to gain $30. Gain. That's how much I want. So I still want my 1,000, but I also want the additional 3%. So here's the thing that I want you to focus on right here. This 1,000 right here, that's the money that I started off with. And if I just kept all the money that I started off with, I would have 100%. So I'm always going to start with 100% of my money. And if I keep 100% of my money, that means my money would just stay the same all the time. So what I actually want is $1,000, and then I want to multiply that by 103% every year. So again, 103% represents I started with 100% and then I gained 3%. So let's see, if I say years and then how much money I have, at 0 years, I would just have $1,000. After 1 year, I would have $1,000 times 1.03. So remember, if the decimal is here, I move it over 2 times to get the decimal. So that would be, actually, let's go ahead and use that calculator here. 1,000 times 1.03. 1,030. Okay, so after 1 year, I have $1,030. Now, the nice thing about interest is that on year 2, I don't just gain another $30 because now we're going to say 1,030 times 1.03. So now I've got 1,030 times 1.03. So now I have $1,060.90. Okay, now after 3 years, I'm going to have $1,060.90 times 1.03. Now I have $1,092.73. We round up here because we're dealing with US dollars here. We only use 2 decimal places for that. Now at this point, I could keep on doing this over and over again, but you can see this is starting to get a little bit tiresome here. So I want to find a faster way to work through this. I'm going to go ahead and just delete these calculations here. Now, just like we've done this a little bit before, I'm going to erase this. This 1,030 right here was actually the first line, 1,000 times 1.03, but then I multiplied it by 1.03 again. And then if I take that 1,000 times 1.03 times 1.03, I could do it again times 1.03 again. And hopefully we're seeing a pattern here that instead of doing this, I could have said this is 1,000 times 1.03 to the third, and this is 1,000 times 1.03 to the second, and this is 1,000 times 1.03 to the first. And for 0, I could say 1,000 times 1.03 to the 0, and since anything to the 0 power is 1, it would turn into 1,000, so that works. So one of the things that we're going to be doing is writing an equation for a situation. So this would be after X years, or sometimes we use T's per time. So after X years, how much money do I have? I would have 1,000 times 1.03 to the X power. So this is going to lead us to our exponential growth / decay formula. So we're going to have y is equal to a times 1 plus r to the x power. So let me switch colors here. X is the input, and in this case it's usually time. Y is the output, so in this case this would be the number of years. A is the starting amount. And R is the percent growth or decay. Now, a quick note here that if it's growth, this is going to be positive. If it's decay, it's going to be negative. One other thing, there's this 1 right here that just kind of showed up out of nowhere. That 1 represents 100%. Because remember, when I first start off, I have 100%. I haven't gained anything. I haven't lost anything. I'm just at 100%. So, quick example. What if I gave you a different scenario? What if I said I've got y is equal to 5,000 times 1.025 to the x? If I asked you to tell the story here, well, this person, they started off with $5,000 and they're gaining 2.5 interest every year. So I could change that to 1 plus 0.025. And then if I took that and moved the decimal 2 spots back, I would say this is a 2.5% growth rate. Now another scenario would be y equals 10,000 times 0.8 to the x. So if I look at this, the 10,000 is the starting amount. That's pretty easy to deal with. But now I need to change this into 1 plus something. What number do I add to 1 in order to turn it into 0.8? Well, that would be 1 plus negative 0.2. So what that means is that in this case, moving the decimal point over 2 spots, that means that this one right here represents a 20% decay. So that means this person would be starting off with $10,000, but then losing 20% of their money every year or month or week or whatever X stands for in this case. Okay, so let's try doing a full word problem here. Let's say you invest in a taco truck. How much did we invest? You invest $5,000 in a taco truck. Due to poor location, you lose 15% of your investment every month. How much is your investment worth after 2 years? Okay, so in this case, we would say y is equal to a times 1 plus r to the x power. So in this case, we would say that y is the amount of money that my investment is worth, where x is the number of months. Okay, a is my starting amount, so a is going to be 5,000. Now I have this 1 here that stands for 100%, plus now I'm losing 15%. So remember 15%, I'm going to take that decimal point, which goes right there. I'm going to move it over 2 spots. So it's actually going to go right there. And this is losing money. So that means this is going to be negative 0.15 to the x power. So simplifying that, we would get y equals 5,000. 1 plus negative 0.15 would be 0.85 to the x. Now, a lot of the exercises are going to ask you to put together an equation for the situation. If the task is to just put together an equation for the situation, this would be the equation. However, this one says, how much is your investment worth after 2 years? So 2 years, remember the variable says months. So since we're talking about 2 years, we know that 1 year is 12 months. I can spell, I promise. 1 year is 12 months. So that means that we are talking about 24 months. So now I can just say y equals 5,000 times 0.85 to the 24th power. And I can go ahead and just use my calculator here. 5 times 0.85 to the 24th power. Well, that's embarrassing. 5,000 times, oh, I forgot the asterisk there, 0.85 to the 24th power. 101.1636, but of course we're talking about money here, so we would round 101.16. So this is a word question. We should answer in words. After 2 years, your investment is worth $101.16. So you should probably change the location of your taco truck to make sure that you are growing your investment. But that is how we solve exponential growth and decay problems.